So I'm going to be talking a little bit about how we automated our simulations with AWS. And AWS is Amazon Web Services. I'm not sure if you know what that is, but basically it's Amazon's platform that allows you to run your applications on the multitude of servers that they have. And automating simulations was something that I did independent of the ZeroRobotics game as a way to help our team basically account for things that I'll explain in the next slide. Alright, so why are we automating simulations? The biggest reason is that each simulation is basically random. There's random factors that occur in each simulation. So if you were to test a piece of code and you were to simulate that one code, let's say you simulate it 10 times, each of those simulations would be unique because of the randomness that ZeroRobotics introduces in the simulations. So one way they introduce randomness is dependent on the game. So in this year's game, randomness could be due to the fact that the target sphere starts in different locations. So if you were to simulate it 10 times, then the starting location of the target sphere that you're hooking onto would be different. And that's why the simulation outcome would be different. And another reason that there's randomness in simulations is that ZeroRobotics injects randomness in each of the simulations as a way to account for the noise that occurs in space. So basically to aggregate the factors in space that cannot be simulated in their API. And then another big reason why we wanted to simulate our code was to create an objective way to compare our code within each other. So for example, this is my yours code, and we ran it 50 times. And this way we could find that, okay, my yours code averages, let's say, around 31 points, and it has this standard deviation. And then we could objectively choose my yours code to submit over another person's code. And this is really important because we have such a large team, and it's especially important in the alliance phase of the competition where we're working with other teams, other international teams. We want to be able to say that even if we're ranked lower than those teams, we might have code that objectively we can show is better. As long as we were to simulate it multiple times, a lot of times actually, we can show that it will perform better when we submit it. And the last reason why we would want to automate our simulations is to find optimal constants. And the constants I'm talking about is, for example, when Jagdeep was talking about Dijkstra's algorithm, in order to calculate the weights, he said that we would use like the alpha 1 and alpha 2. So if we were to be able to simulate a ton of times, then we could try all different kinds of alpha 1 and 2s and see which ones will give us the best overall score. And the last thing we were thinking of using, but we didn't really get a chance to do, was to use gradient descent. And let's say that these were alpha 1 and alpha 2 in Jagdeep's example. We would want to be able to have a test and then take the derivative of our score with respect to these variables and see in which direction of changing those variables would get us the best cost. So that's something we haven't applied yet, but we were looking into doing. Okay, so when simulating the ZR IDE, I can show you guys. You can only simulate one way at a time, one simulation at a time. So the way you do that is, let's say this is your code. This is actually just blank code, but if you hit simulate, you can see this is the starting settings for that simulation. And once you hit simulate, you only simulate once, and then it will give you back over here in the log. It'll just give you a simulation. You can view the results. So where would we start if we wanted to automate these simulations? So the first thing I did to try to figure out how we can automate the simulations is look at what's actually happening when you hit that simulate button. So essentially what I did is I went and inspected the element and then just looked at the network traffic. So when you hit the simulate button, what's on your client side, what's going to the server, and what are you getting back? So we can see that the first thing is this simulate post. And if we go ahead and look at the post, you can see that we're posting to the ZeroRobotics link, this link up here, with this payload. And this payload is essentially the same thing that you saw earlier when I was showing you the settings for that individual simulation. So it's just sending over the settings for the simulation that you want. And we could also see the two added settings that weren't in that white box earlier is the code 1 and code 2. And code 1 would just be the code that you want to actually simulate. So there are some other headers and things that you need in order to get this to work. But the gist of it is we're posting this request. And then the next thing that you do is we're looking. This is a get request. So we go back and we get from the server at this request URL the status of this server. This simulation ID. And with that request, the get request, we get back a status variable, and the status in this case is simulating. So we keep doing that get request over and over again until eventually we'll get a succeeded status. And at that point we know that the server has responded back telling us, okay, a simulation has been created. So again, this is just screenshots of what we just looked at. So we wait for a succeeded simulation, and this is just the overall flow for when you're trying to get when you're trying to simulate and get something back. You do the HTTP post with your simulation settings, and you keep getting back. You keep sending requests asking for the status until the status is returned. And once the status is returned, then we know that we've actually gotten a simulation back. But the simulation you get back is in this visual format, right? It shows like the satellites moving visually, and how do we actually get the data we want from this visual format? Well, what we found out is that with each visual simulation, they actually have JSON data attached to that simulation. And that JSON data for each simulation contains things like what the score is. It looks like this. It's really actually a big mess of data because it's a kind of a large simulation. So they give us data, like all this data is organized in this way, so we had to kind of sift through the data and find the things that we wanted. For example, we want to get the score for red and blue side. We were able to find that in the JSON data. And let's say we wanted to actually test those other things I was talking about earlier. We want to test, like, let's say we want to test how long it takes to get from one point to another point. We could actually just do a debug print in our code, and then the JSON data actually contains the debug print. So we just sift through that data, look for our own prints, and then find whatever time we wanted to calculate. Okay, so now I'm going to talk about how I used AWS to automate the process so that everyone on our team could very easily just go to a website and simulate as many times as they wanted with whatever code they had, and it would make it pretty easy for them. So the first thing I did was I set up a website using Amazon's S3, and S3 is just Amazon's like bucket service. It allows you to store any kind of data that you want. It's basically just like it allows you to make repositories, so you can store anything you want. So what I did was I stored a static web page there, which is just some HTML, CSS, JavaScript, and CSS, and then I have the web client go to this IP address, and then you could actually just grab a web page which would contain all the information you wanted to simulate. And then right here, I used Amazon's Route 53, so I actually set up a simple domain name for free, zr-autosyn.tk, and this routes the address using a DNS server and the name service of this IP address to get to the host IP address. So we can see that the web page you would get back if you were to go to zr-autosyn.tk is just this simple web page which contains, you enter your code here, the number of sims, a session cookie which is basically just gives the author, and then once the simulation is run using the Lambda function, once you get the data back that you specified on the web page, it's going to set up a Google Sheets using the Google Sheets API, and then just email you at the email you entered with the name with the link to the Google Sheet. And then you can see if you click on the Google Sheet, you'll see it real time automating the process of it, of the simulations. Okay. So if I could show you really quickly what the Lambda function looks like. So you can see here that the Lambda function is triggered by the API gateway, which I explained earlier. And all the Lambda function does is we're using the post and the get request that I explained earlier, and the Google Sheets API to send an email of your simulation response. So I can do a sample one really quickly here. I just filled in some simple information, tests, with no code, and then I have the session cookie, and then I would submit it. And then if I go to my email, say this is from earlier, I get an email from the Quark Charm, and that contains the link to a Google Sheet that it created, and that just contains all the response to the simulation. So when I simulated, I requested a score for the blue side and then the link. Now, the reason using AWS is so powerful is because a Lambda function actually takes advantage of what we call serverless computing, and that allows us to emulate requests from a ton of different computers. So, when the web client asks for a simulation, like 10 simulations, and it goes through the API gateway, the API is going to send to a bunch of different servers, depending on the resources that we need. It'll send, let's say, if we want 10 simulations, it'll send to 10 servers and have each of those servers do a simulation each. So it looks like it's coming from 10 different computers. And serverless computing is basically what I explained. It allows you to use servers based on the resources you need. So if we need 100 simulations, then Amazon will give us the correct amount of resources for those simulations. And that's basically it. So now I'm going to give it to Sunny to talk about what we do with the data that we